Okay, again we're looking at which expression simplifies to this statement. These properties of exponents are really important. So we're looking at making sure that all of the variables move around to where they're supposed to. The things we need to remember for this problem, it looks like we need to know what negative exponents do. And negative exponents we talked about are unhappy exponents. And so if they're unhappy, they need to move. Either if they're on the bottom, they need to go to the top, or if they're on the top, they need to go to the bottom. We also need to know that if I have an x on the top and an x on the bottom, those cancel out. If I have 3 x's on the top and 3 x's on the bottom, those will also cancel out. And I really think that's all we're going to need to know for this problem. Okay, so we're looking for x to the 6th on top and y to the 7th on the bottom. What I'm looking at here tells me that all of my x's need to be on top and happy, and all of my y's need to be on the bottom. So if I end up with y's on the bottom, or x's on the bottom, then my problem will be incorrect. Or same thing goes for if y's end up on the top. So let's first just take a look at each one. So if I did this, I would have y to the 3rd would go to the bottom, and x to the negative 2nd would go to the top. That 9 stays on the bottom, by the way. Also, this x to the 3rd would go to the top. So I end up with 3 x's on top, and this x, that's 4, and another 2 x's, so that's 6 x's on top. On the bottom, I would end up with 4 x's on the bottom, and 3 x's on, or 4 y's on the bottom, and another 3 y's, so I would have 7 y's on the bottom altogether. And I also have 3 over 9, and 3 over 9 simplifies to 1 over 3. So I'm thinking that this actually is the correct answer. Let me do one more example just to make sure. So if I moved these y's to the bottom, because they are unhappy y's, and if I move these 2's to these 2 x's to the top, because they're unhappy on the bottom, I would end up with x on the top and another 2 x's, so that would be 3x on top, so x to the 3rd on top. I would end up with x to the 3rd on the bottom, and I would end up with, let's look at the y's, y to the 4th on the bottom, and another 3 y's that move to the bottom, so I end up with y to the 7th on the bottom. And I still have the 3 over 9, which does simplify to 1 over 3. So I would have x to the 3rd over 3x to the 3rd, y to the 7th. But since these are both on the top and the bottom, I actually just end up with 1 on top, and that's not what we're looking for. So again, I'll show you how I got this with A in case you missed it the first time. So for A, I have 3x on top. I also have x to the 3rd that moves to the top. Okay, on the bottom, I have a y to the 4th. And that's all just from the first statement. This statement says that this y is unhappy and needs to go to the bottom, so I also have y to the 3rd on the bottom. This x says x to the negative 2nd, unhappy, goes to the top. So I get x to the 2nd on top. And on the bottom I have a 9. So if I look at these, x times x to the 3rd times x squared would end up with x times x times x times x times x times x, which gives me x to the 6th. This would be 4 y's, y times y times y times y, and then 3 more times y times y times y. So I end up with y to the 7th over 9. And we know this fraction simplifies to 1 over 3, which is what we would get if we put a 1x to the 6th in front there. So we get, our answer is